In this video, you will learn to solve equations with the variable on both sides of the equation. So example 1, we have 8x equals 6x plus 18. So the objective when you have the variable on both sides is you want to bring them together on one side, because your final answer needs to be something like x equals a number. So we have x by itself. So we need to bring either the 8x over with the 6x or the 6x over with the 8x. Now there's not one set way you have to do this, but usually the easiest way would be to make sure the x is not negative. So for me, I'd like to take the 6x and bring it to the left side with the 8x. So the question is, well, how do you do that? So I want to get rid of it on the right side. So to get rid of it, I can simply subtract. If I subtract 6x, I have 6x minus 6x, which would give me 0. That would cancel out. But I can't do that unless I do the same thing on the left side. So if I subtract 6x on the left side, now the equation is balanced. So what I'm doing is I am subtracting 6x on both sides. So when I do that, on the left side I have 2x, and then on the right side I'm left with 18. Now I can solve this very quickly, because 2 times x means I must do the opposite of multiplication, which would be division. So I divide both sides by 2. Divide both sides by 2. I have x on the left side, and on the right side I have 18 over 2, which would equal 9. So my answer is x equals 9. Example 2, I have 4y equals 14 minus 3y. So once again, I want to get y on the same side. So the easiest way would be to bring this negative 3y over to the left side with the 4y. Well, to do that, I need to get rid of the minus 3y. So I will do the opposite of subtracting 3y, which is adding 3y. If I add 3y on the right side, negative 3y plus 3y would cancel. That gives me 0 y's. And then on the left side, we add 3y as well. So on the left, we have 4 y's plus 3 more y's. That would give me 7 y's. And on the right side, we have 14. And then to solve this, 7 times y equals 14. I divide to get rid of the 7. And when I do that, I now have y on the left side and 14 over 7, which is 2 on the right side. So my answer is y equals 2. Example 3, I have 3/4 y plus 5 equals y. This one is a little more tricky because we have the fraction, but the process is still the same. So I want to bring the y's together, and the easiest way would be to bring the 3/4 y over to the right side of the equation. Well, to do that, I can subtract 3/4 y, because a positive 3/4 y minus 3/4 y would cancel. That would be gone on the left side. So on the left, I'm left with the number 5. And on the right side, I have y minus 3/4 y. Now the tricky part is going to be combining the like terms. So here I have 1y, it's an assumed 1 in the front, and then minus 3/4 y. When I combine, I look at the coefficients. So I have 1 minus 3/4. So 1 minus 3/4, and then whatever that is, that's going to be the coefficient. So what is 1 minus 3/4? Well, we need a common denominator. So 1 is the same thing as 4 over 4. So now I can subtract. We have 4 minus 3 gives me 1. So that would be 1 over 4 times y. Now we need to get rid of the 1/4 with the y. So to do that, I have to divide both sides by 1/4, which is the same thing as multiplying by 4 over 1. So I multiply both sides by 4. On the right side, the 4 and the 1/4 would cancel. That gives me 1y. And on the left, we have 20. So my solution is y equals 20. Example 4. We have 7 plus x over 9 equals x. So here, we do want to get x by itself on one side, but it's going to be easier if we get rid of the fraction first. So remember, the 7 plus x is one quantity, so I really cannot just subtract x from both sides. Alright, so I need to get rid of this 9, and this is being divided, so the opposite of division is multiplying. So I multiply both sides by 9. The 9's on the left side will cancel. I'm left with 7 plus x on the left, and on the right we have 9x. So now I can actually bring the x over to where it needs to be. So let's bring this 1x over to the right side with the 9x. To do that, I can subtract x, which is the opposite of adding, because x minus x will cancel. That gives me 0 x's, so that's gone on the left. And on the left I have 7 remaining, and on the right I have 9 x's minus 1x, which gives me 8 x's. And then to finish off, I need to get rid of the 8 with the x. So to do that, this is 8 times x, so I get rid of it by dividing. So divide both sides by 8. The 8's will cancel on the right side. On the left, I have 7 over 8 left over. So my solution is x equals 7 over 8. Example 5. We have a lot going on here. We have to distribute, we have the letter b on both sides, we have numbers thrown in. So what I want to do is first simplify. So what I mean by that is we see the 7 times b minus 2. We need to distribute first. So 7 times b gives me 7b, and then 7 times negative 2 is negative 14. So I have 7b minus 14, then minus 6, equals, on the right side, 2b plus 1b would give me 3b's, and then plus 8 over here. Alright, and on the left side I can simplify further. Negative 14 minus 6, that would give me negative 20. Alright, so from here, I want to get the b's on the same side. So the easiest way would be to bring the 3b over to the left side with the 7b. So to do that, I can subtract 3b for both sides. On the right side, this would cancel. I'm left with an 8 over here. On the left side, I have 7b's minus 3b's, which gives me 4b's. And then also the minus 20. So now I've brought the variable to the same side. I've simplified. Now I can solve. Remember, to solve, I do reverse order of operations. So I begin with addition and subtraction first. So we see here the minus 20. I need to get rid of that first by adding 20. So when I add 20, this left side will cancel. I have 4b equals 8 plus 20, which is 28. So now to finish off, this is 4 times b. So I get rid of the 4 by dividing. So I divide both sides by 4. The 4's cancel. I have b on the left side, and on the right I have 28 over 4, which would equal 7. So my solution is b equals 7. 2 more examples. Example 6, we have this expression to simplify, or to solve. So I begin by simplifying, and then I want to bring the variables all together, and then I can solve. So here, it's kind of like the last one. I need to distribute the 2. So I have 2 times negative x. That gives me 2, then minus 2 times x. And then over here, 2 times x would be 2x, plus 2 times 1, which would be 2. Alright, on the left side, I can simplify from here. Negative 2x plus 5x. That would give me a positive 3x. Okay, now I'd like to bring the x's to the same side. It'd be easier if I bring the 2x to the left side. And I do that by subtracting the 2x. So if I do that, on the right side, those would cancel. I'm left with a 2 on the right. And on the left, I have 2 plus 3 minus 2 would be 1x. Okay, then to finish off, I need to get rid of the 2 that is over here with the x. So the 2 is being added. So to get rid of it, I subtract. So this would be x on the left side, 2 minus 2, which is 0, on the right side. So my solution is x equals 0. Last example. We have 1/3 times 12x minus 18 equals 4x minus 6. So once again, the first thing I want to do is I want to distribute, which will help me to simplify. So I take 1/3 times 12x and 1/3 times negative 18. That's the same thing as thinking of this as 1/3 of 12. So 1/3 of 12 we know is 4. 12 divided by 3, so that would be 4x. And then 1/3 of negative 18 would be negative 6. Alright, so this is kind of weird because we have the same thing on both sides. 4x minus 6 equals 4x minus 6. If I try to continue to solve this, I would bring the x's together. So bring the 4x, I guess bring the right one to the left side. We can do that by subtracting. And on the right side, this would cancel. I have negative 6. And on the left side, this would cancel too. I have negative 6 as well. So this is an unusual situation where we have a true statement like this, but without variables. So if you see this, like negative 6 equals negative 6, or 0 equals 0, or 4 equals 4, this is a special scenario where our solution would be all real numbers, meaning there's an infinite number of solutions. It could be any number, and we would still have a true statement. And if you want to write this shorthand, instead of writing out the whole phrase, all real numbers, you can write a fancy R. So it looks something like this. And that symbol means all real numbers. If you went through the same process and you were to get something without variables again, let's say it was like 0 equals 1, where it's not a true statement. If that happens, your answer then would be no solution. And the shorthand way of writing that would be a 0 with a line through it. That means no solution or empty set. Alright, well that concludes our lesson for today, and we will see you next time.